Hey y'all. Okay, we're still here in the chapter 10 problem set, and now I'm going to go over question number 8. This is testing for homogeneity of variance. So if you remember from the PowerPoint, one of the main assumptions of the independent t-test is that the variance is equal. Right? That the two groups have equal variance. So this assumption is called homogeneity of variance, which means that the variance is the same. And so I have to test for this because if it's not the same, I have to make a correction. All right. So I have to identify if I can do an independent measures t-test. So let me read this. So she wants to know about a new plant that affects appetite. So she randomly assigns 18 rats to a treatment or control group. So I have 9 rats in each group. So I have the same number in each group. The rats in the treatment group were given the plant compound daily for a week. The control group rats got a placebo. The researcher monitored the total number of calories consumed by all 18 rats. All the rats were kept separate from one another, but in their typical environments for the week. Okay. The null hypothesis is that the rats given the plant compound consumed the same number of calories. The rats in the treatment group are independent of the rats in the control group. The researcher knows that the total number of calories consumed by a rat over the course of the week are normally distributed. But she's not sure if the variance is the same. Okay, so the question is, the researcher is unsure of which of the following required assumptions are here. Are the observations within each group independent? We already know they are. Are the calories consumed by each group normally distributed? Yes, we already know that. Are the groups kept independent of one another? Yes, we know that. So this is the question we don't know about. Is there homogeneity of variance? She also said that she's not sure about the variance. So we have to do an F-max test. If you go back to the PowerPoint, you will see that the F-max test takes the largest variance divided by the smallest variance, and that gives us our value. So I see here that the question gave me the standard deviation, but not the variance. So to get the variance from the standard deviation, you simply square it. So the largest one is going to be this one, and so I'm going to do the other one first. So I'm going to do 39 squared, and I get 1521. Now I'm going to do 87 squared, and I get this number. So I'm going to divide by the variance that I got a minute ago. So basically I take each standard deviation, square them, and I divide the bigger one by the smaller one. I end up with 4.97. So now that I have my F max value, I have to figure out if it is in the critical region. So I'm going to use this table below. If you forget how to use it, remember that the instructions are in the PowerPoint. So K is the number of separate samples I have, and the degrees of freedom is my n-1 for each sample. So I have 2 samples, so that's K right here, the 2 samples. And I'm using an alpha value of 0.05. So in this table, I have to find my degrees of freedom and my number of samples. And depending on whether it's 0.05 or 0.01 is which number I look at. So in this case, I need an alpha of 0.05, which is the regular type. if you have to look for an alpha of 0.01, you're going to be looking for the bold words, the bold numbers. Okay, so I had remembered 9 rats in each group. So my n minus 1 for each sample is 8. So I have a n minus 1 of 8, number of samples 2, and I'm looking for the regular font, 4.43. That is my critical value for the Fmax test. You'll notice that my Fmax is larger than the critical value, which means that my variance is significantly bigger than I want it to be. The Fmax, the F test is only a positive test, so it's only the first, like one side of the bell curve. An Fmax of 1 means that I have exactly equal variance. Because just imagine if I had a variance of 3 divided by a variance of 3, the result would be 1, right? Anything that's higher than 1 is going to be unequal. So in my case, my Fmax critical region was 4.43. And so anything past that is considered extremely, different from each other. So I have violated the assumption. My value of Fmax was 4.976, which would be in the critical region somewhere, right? It would be like over here, 4.9. And so this falls into the critical region, and so I have violated the assumption. So given the results of my Fmax test, the researcher's conclusion is that the data suggests the homogeneity of variance assumption has been violated. Now, if my Fmax test, if this number right here was smaller than 4.43, then I would be fine. But it's larger. Can you still use the independent measures t-test if the homogeneity of variance assumption is violated? You can, but I have to, I would end up with this. I don't use the pooled variance and I recompute the degrees of freedom so that the resulting degrees of freedom is smaller. I think that one's right. Let's find out. Right, so I want to use a smaller degrees of freedom so that there's less like movement or whatever. Now, what we're looking at here is the formula that we would use if we were going to conduct the independent measures t-test. I'm not going to go through with it all because you don't actually need it for any of the questions. But this new degrees of freedom value will be smaller than the original one, and so a smaller value will result in the critical value being more extreme, making it more stringent, basically. So because I have violated this assumption, it'll be a little bit harder to reach the critical region for my t-test, which is a good thing.